Hello friends and welcome back. So today's topic for discussion is software development life cycle and different stages of SDLC. We will understand everything in details along with the examples. So without wasting any time, grab a notepad and let's begin. So what is software development life cycle? Software development life cycle is a process used by software industries to design, develop and test high quality softwares. And the objective is to produce a high quality software that meets or exceeds customer expectations and reaches completion within times and cost estimates. So whatever timeline we have decided and whatever cost we have decided, it should be within that. There are typically 5 to 6 stages which every software development organization follows. One is planning, then defining requirements, designing product, building product, testing, and then finally the deployment part. So we will go through all the stages in details. We will understand what is done at each stage along with the examples. Stage 1 is planning, where planning and requirement analysis is done. Requirement analysis is the most important stage in SDLC. It is usually performed by the senior members of the team with inputs from internal and external stakeholders, domain experts and market surveys in the industry. And then this information is used to plan the basic project approach and to conduct product feasibility study in the economical, operational and technical areas. Consider a hospital which wants to implement a hospital management system to enhance patient care, streamline operations and improve efficiency. In the requirement analysis stage, senior team members collaborate with healthcare professionals, administrative staff and industry domain experts to gather essential information, which involves understanding patient care needs, administrative processes, and compliance requirements. Subsequently, team may identify key features which are required, such as patient registration, appointment, scheduling, electronic health records, and billing functionalities. Planning for the quality assurance requirements and identification of the risks associated with the project is also done in the first stage. Quality assurance planning involves defining testing protocols for critical functionalities, including patient data accuracy, prescription management, and integration with medical devices. Risks which are associated with the project include data security concerns, potential disruption to patient care during system implementation, or issues related to staff training. In stage 1, after planning and requirement analysis, technical feasibility study is done. The outcome of technical feasibility study is to define the various technical approaches that can be followed to implement the project successfully with minimum risk. This involves assessing the feasibility of different technologies, platforms, and integration capabilities within the healthcare environment. And this may include options such as choosing between an on-premise or cloud-based system, evaluating the system's ability to integrate with existing medical devices, and ensuring compliance with healthcare data standards. Once the requirement analysis is done in the first stage, the next step is to clearly define and document the product requirements. This step aims to capture all essential features and functionalities identified in the earlier requirement analysis stage. The defined product requirements are presented to stakeholders and approval is taken to ensure that the documented requirements meets needs and expectations. The approved product requirements are compiled into a software requirement specification, which is also known as SRS document. This document serves as a detailed guide for the development team, which consists of all the product requirements to be designed and developed during the project lifecycle. In the third stage of software development lifecycle, architects refer to the software requirement specification as a guide and come out with the best architecture for the product to be developed. Based on the requirements specified in the SRS, usually more than one design approach for the product architecture is proposed and documented in the design document specification. Multiple design allows for a thorough exploration of various architectural possibilities. Architects propose different design approaches that may include variations in how user authentication is implemented, the handling of service requests, and the integration of external modules. And each approach is documented in the DDS for further evaluation. DDS is Design Document Specification, which we discussed. Then this is reviewed by all the important stakeholders and based on various parameters like risk assessment, product robustness, where we check if the system can efficiently scale to accommodate increased user loads. Design modularity means to check scope for future enhancements such as changes in billing process or addition of new payment gateway without disrupting the entire system. And other parameters like budget and time constraints are also considered while selecting the best design. What will be the software cost, licensing cost, and to review each stage timeline and to complete within the timeline. The chosen design approach is translated into a detailed architectural plan which clearly defines all the architectural modules of the product along with its communication and data flow representation with the external and third-party modules, if there are any. The internal design of all the modules of the proposed architecture should be clearly defined with the minutest of the details in DDS. Stage 4 is building or developing the product. This is the stage where coding comes in place. In this stage of SDLC, the actual development starts and the product is built. The programming code is generated as per DDS during this stage. If the design is performed in the detailed and organized manner, code generation can be accomplished without much hassle. Developers must follow the coding guidelines defined by their organization, and these guidelines may include naming conventions, indentation rules, and best practices established by the development team. Programming tools like compilers, interpreters, debuggers, etc. are used to generate the code. And these tools aid in the generation of executable code, interpretation of scripts, and debugging to identify and fix any issues in the code. Different high-level programming languages such as C, C++, Pascal, Java, and PHP are used for coding. And the programming language is chosen with respect to the type of software being developed. Like PHP could be used for web-related functionalities due to its server-side scripting capabilities. Stage 5 is testing the product. This stage is usually a subset of all the stages. As in the modern SDLC models, the testing activities are mostly involved in all the stages. However, in this stage of the product, defects are reported, tracked, fixed and retested until the product reaches the quality standards defined in the SRS document. Next stage is deployment. Once the product is tested and ready to be deployed, it is released, making the product available to users for consumption. Sometimes product deployment happens in stages as per the business strategy of the organization. The product may first be released in a limited segment and tested in the real business environment, which we call as user acceptance testing, UAT testing, which is done, which allows for further validation and refinement if required. And based on the feedback after UAT, the product may be released as it is or with suggested enhancement in the targeting market. So there are different SDLC models which are widely used by different organizations. We will discuss only the most widely used model, which is Waterfall Model. Waterfall Model is a linear and sequential software development approach where each phase must be completed before moving on to the next. It consists of distinct phases such as requirements, design, implementation, testing, deployment, and maintenance. And once a phase is finished, it is challenging to revisit and make changes, making it suitable for projects with well-defined and stable requirements. The model provides clear milestones and is easy to understand, but may face challenges when dealing with evolving or dynamic project requirements. Then there are some other models as well, which is iterative model, evolutionary model, prototype model, spiral model, RED model, agile model, incremental model. So maybe we will discuss the other models in upcoming videos. I hope you got really good insights from this video, and if you have learned anything new, do subscribe and share it with your friends. Consider joining me on LinkedIn. See you soon with another topic, another module soon. Thank you. Bye-bye.